Good morning, and thank you for tuning in. This is How AI Will Change Healthcare Forever. My name is Christopher Penn, co-founder of BrainTrust Insights. Today we want to talk about healthcare from the voice of the patient and how artificial intelligence stands to change the way healthcare works. Healthcare is facing a data tsunami, a massive wave that's coming that has four dimensions. IBM calls these the 4Vs, if you will. Let's go through each of these to help understand what's likely to happen. Number one is volume, the first V. According to Gartner, IBM, and Cisco, the Internet of Things, including the Internet of Medical Things, these devices, these sensors, these medical devices, are going to generate 120 zettabytes of data by the year 2025. To put this in perspective, today, all devices on the internet, everything that you do from your smartphone to your laptop to the X-ray machine generates only 30 zettabytes. So just these little devices, just these little sensors are going to quadruple the amount of healthcare information, healthcare data that we all have to wrestle with. And it is a massive, massive change. Just to give you some perspective, 1 zettabyte, by the way, is approximately, I think, something where there are several million hours of Netflix. So it's a lot of data. The second problem we're going to be facing is a problem of variety, the variety of data that we're going to be asked to process and draw conclusions from. For fun, this is a partial look at the insides, the schema of one EMR system, one electronic medical record system. There's about 70 some odd tables, so complex, so interlinked. And here's the thing. This does not include images. This does not include diagnostics. This does not include charts. This does not include audio. It does not include video. It does not include sensor data. This is just what we as healthcare practitioners will be putting into a system now. That just gives you a sense of how diverse the data is going to get. It's going to become a very, very complex, messy way of tracking all of our data. And if we don't have systems that will help us process it quickly, we will not be able to extract usable insights from it. The third V is called velocity, the speed at which data is coming at us and our ability to process it. For those of you who've worked with things like echocardiograms, there are now dozens, if not hundreds, of different healthcare sensors that you can buy, from sport sensors like the Fitbit to actual full-on SpO2 sensors that you attach to a patient. All of this information is happening in real time, and our ability to detect anomalies and do something about it is measured in milliseconds. We don't have time to process data once a week to help someone who's having a cardiac arrhythmia. We're going to need to process that 120 zettabytes of data in near real time. So those are the three. Actually, I'm sorry. There's one more V, the veracity. How truthful is our data? We have right now, and are going to have for a number of years, a delicate balance between the privacy of the healthcare patient and the outcome we're going after. We are seeing right now in the broader macro picture a tremendous backlash against companies just having too much access to too much data. And so this balancing act of weighing privacy and outcome is going to get trickier because we want and our machines need as much data as possible to draw really great conclusions, but at the same time, we have to deal with all the privacy concerns, from protected health information and how it's encrypted to the speed at which we can access it. All four of these problems, volume, variety, velocity, and veracity, are problems that, if we get them wrong, have disastrous consequences. I work in the marketing sphere, and if I get something wrong, okay, we make 5% less money. When healthcare gets something wrong, people's lives are literally in danger. So how do we avoid disconnecting from our data? How do we avoid potentially preventable outcomes that instead, how do we get to what people really want? We really want better answers, faster, from our machines. The answer, or one of the answers, I should say, is artificial intelligence. Artificial intelligence has three main promises: faster, better, and less boring. So the first A is acceleration. Because artificial intelligence is largely about mathematics and statistics, machines way better than we are at mathematics. And so the accuracy, or the speed at which we get results, is going to be much, much faster. When machines are crunching through those massive troves of EMRs and EHRs or IoT or IOMT data, machines can just get to the answer so much faster than we can. 2 is accuracy. We're human. Humans make errors, and humans frankly don't get better with age, whereas machines, as software evolves, of course, do get better and do get faster. So our accuracy, the accuracy of the results, will get better. And the third thing, and probably one of the most important things about artificial intelligence when it comes to healthcare, is the alleviation of repetitive tasks. For those of you who have experience as providers, what percentage of your time is spent on administration? Right? This is probably the least fun part of the work that you do. It's the least meaningful, but yet it consumes an inordinate amount of your time that could be spent doing things like curing diseases, fixing injuries, helping people feel better, helping people become better. And so artificial intelligence can help us reduce those tasks so that we can focus on what we're really best at as humans, which is helping other humans. So what is artificial intelligence? It is teaching machines to do things that humans can do naturally. So humans can see and hear, process language, and think. Machines, we are trying to build our machines to do the same thing, to go from statistics and algorithms to natural language processing to what's called deep learning, or really just very, very powerful combinations of artificial intelligence techniques. AI is broken up into 2 fundamental realms. One's called machine learning, the other's called deep learning. Machine learning is mostly math and statistics, and there's a whole bunch of really fancy names for the different types of machine learning techniques, but at the end of the day, they all boil down to math. Let's look at a couple of examples. Suppose you have a bunch of blocks on a table. One of the types of machine learning is called supervised learning, where we take a pile of data and we ask a machine to look for an outcome. So in this case, in those pile of blocks, we would train a machine to look for the color red, and eventually it could identify from any given picture the color red. This is a red block. We show it to the machine over and over again until it gets it. We see supervised learning be applied in diagnosis, especially. One of the more famous stories is IBM Watson was able to sequence a patient's genome and then process 233,000 journals of oncology and identify that a patient was being treated for the wrong type of leukemia. Using supervised learning, it identified that it was the wrong type and provided counsel to the treating physician that, no, you need to treat a different kind, and the woman, of course, made a full recovery. And again, going back to those 3 A's, it's not that IBM Watson just did this. It did the whole thing in 11 minutes. The second type of machine learning is called unsupervised learning. Instead of looking for a specific outcome, we want to be able to categorize a large amount of data. Imagine these blocks on a table. Now imagine 1 billion of them. Imagine this whole auditorium filled with blocks. There's no way that you could easily categorize all these blocks by things like colors or shapes or sizes. But with unsupervised learning, we can do exactly that. We can sort them in all these different ways to find out and to organize data. We are seeing this happen right now in pharmaceutical research, especially, where machines connected to cameras can, instead of looking at 1, 5, or 10 different pharmaceutical tests, you can have 1 million tests running at the same time. And the machine's computer vision goes and identifies, yep, this group over here worked, this group over here did not work, and be able to develop and deliver drugs to the market much, much faster than previously possible. And of course, the final area is called deep learning, which is where we string together many different types of machine learning to get this deep learning to exceed what any one technique is capable of and exceed what we as humans are capable of. I want to take a moment to answer the quick question you're thinking. Okay, well, this sounds great, but what can machines do and not do? One of the things that machines are best at is this green section here, the known knowns. We know what we know. We know what cancer looks like. We know what data goes into a genome. And so a machine can make that better and faster and reduce the repetition. Machines are not as good at questions of we know what we don't know, we have to go research it, or we don't know what we know and we have to go catalog it. And that's where more traditional techniques like data science would take place. And finally is in the we don't know what we know. That is pure research, and that is something that while artificial intelligence may be able to tactically help with certain tasks, there is absolutely no push button answer to some of our greatest medical questions, and that is where we as practitioners still need to play a vital role in the healthcare process. So let's look at a few applications of these techniques. I was focused today on the voice of the patient. The voice of the patient today means so much more and is so different than what it used to mean 20, 30, or 50 years ago. It used to be the voice of the patient was just what the patient said to the provider. Hey, doc, this hurts. And the doctor says, don't do that. There is so much more now. There are electronic health records, electronic medical records. There are the conversations people have on social media and sharing of knowledge, not necessarily correct, but it's part of the voice of the patient. There are people who leave reviews about your healthcare practices online. Believe it or not, go and check out. I was looking at kidney dialysis centers, and people leave reviews on Yelp of their kidney dialysis experience. There are all the external conversations that we have with providers, with insurance companies, with all these different entities as part of the healthcare experience as patients. There are support and advocacy groups where for different disease states we interact with people. We have conversations, again, online and offline in closed communities. Still part of our healthcare experience. They're the things that we search for. We search for stuff online that we would never ask another human until we get to a point where we have, a sort of an idea. We've been searching WebMD for 3 days, and then we finally have the courage to talk to our provider. There's consumer medical technologies like this lovely watch that I'm wearing here, which is has a heart rate monitor and a blood oxygen monitor and a bunch of other things that whatever Apple decided to put into it. And of course, there are the sensors themselves, from smart pacemakers to even things like smart blood, where we're starting to talk about nanotechnology that records data and shares it back with our provider. Machines that are sharing our healthcare data back to our provider is still part of the voice of the patient. And so there's this massive landscape that we need to address. So let's look at how artificial intelligence is applying in these 4 areas with 4 specific techniques: driver analysis, time series forecasting, unstructured data mining, and conversation. In driver analysis, we are looking for a specific outcome. So let's say that you are in the city of Baltimore and you are a police officer. This is a distillation of 411,000 911 reports. These are the medical ones by section of the city. If I had responsibility for healthcare within Baltimore and was working with the police department, I would want to provide guidance to those police officers. Hey, if you're in this section of the city, this is a likely outcome. This is a likely situation you're going to face more often than other outcomes, say in the central district, someone just laying in the street. Whereas in other sections like northwest part of the city, there's a behavioral crisis. And by having the right tools, the right officers, the right support, you can help create better health outcomes for people who are reporting medical things to the police. So that's an example of driver analysis. We find what's really happening behind the scenes from a massive data set. The second application is called time series forecasting. What if we could look ahead at what's likely to happen? So this is, right now this week, I took 3,600 search terms for all these different disease states, things people type into Google about their health outcomes. What are people searching for? This week, Jardiance is a major thing, along with dog allergies, mold, aspartates, black mold. These are things that people are asking Google about. Wouldn't it be great if you, as a healthcare professional, knew what things were on people's minds, what stuff they were asking them, the search engine about, a machine about, and were able to forecast and plan ahead so that you could staff appropriately, you could maybe publish information, you could even do TV interviews if you wanted. And this is so seasonal. This changes so fast. Here is just what happens in 2 weeks. Doxycycline hyclate becomes one of the top search terms. Well, why? It's an antibiotic that is prescribed normally for acne, which means that when it's back to school season and people have been in school for a week or two, people are starting to ask questions about this. Wouldn't it be great to know that? Wouldn't it be great to have information in advance for your patients so that you could say, hey, I know this is what you're thinking about, or this is one of the things you're likely thinking about. Let me give you some information and improve your patient experience without you even asking me. The third area is unstructured data mining. This is where we take all those conversations, all that text from the conversations we have in our offices to the things we type in online. What are people saying? I took 1,100 reviews of Fresenius dialysis centers off of Yelp and crunched down all of the words people used. Now, if I was working for Fresenius, I would want to know things like, hey, people say it's wonderful. People say it's properly managed. There's quality. They're smart. They're grateful. These are good terms to know. By the way, it would also be really important to do the same analysis with negative terms to see where I could address problems, because part of addressing the voice of the patient is improving the patient experience. If the patients are telling us things via external channels like review sites, but they might not necessarily be telling us that, we still want to know. We still want to have access to that data so we can fix our problems. And finally, the fourth application is in conversations. Everything from building chatbots to how machines process language. This is a very simple example of a chatbot. I put this together with Facebook's chatbot tool. No programming required, just to be able to answer the question of where's the nearest hospital. Now imagine being able to do patient intake 24/7, wherever, whenever, as long as the patient had access to the internet, and be able to build classifiers based on your experience and knowledge of the types of conditions you treat and the work that you do, so that you could have all the information in advance before meeting with a patient. You could create a much better patient experience just with those intake, with that sort of intake. The other thing you can do is literally process the voice of the patient. This is an example of a service called Otter, which takes voice conversations and transcribes them in real time. So imagine, with consent, you're having conversations with your patients, and the machine is transcribing everything that you and the patient are saying, and it goes right into the health record. Now you have a searchable, mineable, indexable space that tells you what's happening in your practice. It might be useful to know that someone was complaining about a certain type of mosquito bite or symptoms, but where this really becomes powerful is when you have a network of patients, and suddenly you start seeing trends in what people are saying. Like, hey, a whole bunch of people are coming in with this cough all at the same time. I know what that is, and I know we need to develop a more coordinated response throughout our practice. The most important thing with artificial intelligence is that you get started now. The sooner you can start, the more impactful you're going to be in improving the patient experience, in listening to the voice of the patient, and ultimately being a better provider of healthcare. So how do you get started? Well, there's two choices you have to make based on time and resources. If you don't have time, if patients are asking for a better customer experience, a better patient experience right now, if you don't have time but you do have money, hire or outsource technology companies and consulting companies to come and do it for you. On the other hand, if you have time but you don't have money, you can build it yourself. All of the examples that I've shared today were things that I built and ran right on my own laptop using one of these two programming languages, and it took a couple of years to get good at them. But these are things that you can do. They are within your reach. How do you prepare your company, your practice, your organization for artificial intelligence? You're going to need three kinds of people, three different skill sets. I love the expression, data is the new oil. It's one of my favorites because crude oil is disgusting, awful stuff. It's pretty useless. You need to extract it from the ground, refine it, and then make it into a usable form like gasoline for it to really be beneficial. The same is true for artificial intelligence. You need developers to extract the data from all those crazy systems, like that massive EMR diagram earlier. You need data scientists to clean that data because it sure is not in usable condition as it is. And then you need technologists to transform the insights into actions you can take. I want to wrap up today by talking about what your career is going to look like with artificial intelligence. We talked about what AI is good at and what it's not good at, but let's talk about the human aspect. Artificial intelligence is not good at empathy. It can't do empathy. It's not there. The machines don't have emotional intelligence. AI is not good at human judgment. It is not good at distilling and understanding the life experience of someone who is a medical practitioner who's seen all sorts of crazy things. And it is for sure not good at maintaining those human-to-human relationships. You want to use artificial intelligence for that acceleration, for the accuracy, for the alleviation and automation of tasks so that you can focus on and double down on empathy, judgment, general life experience, and relationships. And with that, Thank you very much. If you have questions, I know we're on a tight schedule today, but if you have questions, please go ahead and take a picture with your phone of this slide and reach out, and I'll be around for the rest of the conference. Thank you. If you want help with your company's data and analytics, visit BrainTrustInsights.com today and let us know how we can help you.